Émilie du Châtelet was born Gabrielle Émilie Letonnier de Breteuil on December 17, 1706 in Paris. She was born into an aristocratic family and educated at home. She was able to speak 6 languages by the age of 12. She was mostly interested in science and math, however, these subjects weren't recognized as proper for young ladies at the time. Luckily, her father encouraged her interests by allowing her to discuss science, mathematics, and astronomy with prominent scientists he knew who visited him often. She married Marquis Florent Claude de Châtelet at the age of 18 and moved to the countryside in eastern France. Her husband was an army officer who was frequently away from home, leaving Émilie to study science and math. Because women were not allowed to attend universities at the time, her large house became her place of study. She converted many of the rooms into laboratories for her many experiments. She invited scholars to come to her house so she could learn from them. Of those scholars was the writer Voltaire. Émilie and Voltaire wrote the book Elements of Newton's Philosophy, which explained Newton's somewhat controversial ideas about astronomy and optics to the larger population. However, only Voltaire was noted as the author. Voltaire did include a preface in which he acknowledged Émilie, and the illustration in the front of the book depicted her as Minerva, the Roman goddess of truth and wisdom, looking over Voltaire as he wrote. One of Émilie's most important contributions to science was her clarification of the concept of energy. She followed experiments previously conducted by William Gravesand in which she dropped heavy lead balls into a bed of clay. When a ball hit the clay with 2 times the velocity of another, it penetrated 4 times as deep. When a ball hit the clay with 3 times the velocity of another, it penetrated 9 times as deep. Her results suggested that energy is proportional to mv squared, not mv as Newton had suggested. Émilie wrote a physics textbook, Institutions de Physique, that incorporated the ideas that existed about physics at the time. She merged Newtonian ideas about the physical world with ideas of popular philosophers of the time. These views of the world were seen as opposing views. When Émilie found out that she was pregnant with her 4th child at the age of 42, a death sentence at that time, she decided to dedicate the rest of her life to translating Newton's Principia into French. Not only did she translate Newton's work, but she added commentary, examples, and her original thoughts. Her translation became a critical piece in the scientific revolution in Europe. Émilie passed away in September 1749, a week after the birth of her daughter. However, her translation was not published until 10 years after her death, when the return of Halley's Comet renewed interest in Newton's contributions to science. Émilie's work aligns with the next generation science standards on energy and forces and interactions for middle school. She contributed to the definition of energy, and her translation of Newton's Principia into French contributed to the acceptance of Newton's laws of motion and Newton's law of universal gravitation.